Hello everybody, thanks for joining the session. I'm going to present understanding the difference in freight transport estimates with and without road sensor data. This is joint work by me, Jörg Bürger, Bart Bühlens and Rainer Schnell. A brief introduction to our research. So diary surveys may suffer from underreporting due to high response burden. And by linking sensor with survey data and applying capture-recapture estimators, we are able to provide an estimate of the amount of underreporting. Here we're studying to what extent can other factors explain the difference between survey and capture-recapture estimates. Such studies are really required because they strengthen the trustworthiness in combining new data sources with established methodology in official statistics, and then could ultimately lead to the uptake of these methods in statistical production processes. The data we used is the Dutch Road Freight Transport Survey of 2015 with about 35,000 vehicles in the sample. Each vehicle is in the survey for 1 week. The vehicle owners must report the day of loading and all trips on each day. There are 4 response options: using the truck, not using the truck, not owning the truck, and non-response. The survey is mandatory, so non-response is not a major issue here. Second, we used the Way Motion Road Sensor data, also of 2015, with about 36 million observations. In the Netherlands, there are 18 stations continuously measuring the weight of passing trucks and the passing truck itself. On the map, you see the state roads in the Netherlands and crosses and circles indicating the sensors. It's only crosses and circles to indicate or to show overlaying sensor stations. There is no difference in the sensors. We have auxiliary information from the National Vehicle and Enterprise Register, and we can link all these data sources by a unique key, which consists of license plate and day. In this research, we have 2 target variables. One is the total number of vehicle days, denoted as big D, and the total transported shipment weight, denoted as big W. So this is showing the results of linking survey and sensor data. I will only explain the upper table using number of vehicle days. The lower is showing the same, but just the transported shipment weight. So as you see, by the result of linking the data is that we have about 9,700 observations or number of vehicle days, which are not reported in the survey, but are measured in the sensors. And there are about 34,000 vehicle days which are reported in the survey and measured in the sensors. What we're going to estimate is this cell, so what is not reported in the survey and not measured by the sensors, so the unseen part of the population. And what I just said applies in the same way for the transported shipment weight. The methods we use are first log linear capture-recapture estimator. To select appropriate covariates from the registers, we used BIC-based model selection. Variance estimation was done by applying bootstrapping, and the potential alternative explanations we study are reporting errors, where we simulate questionnaire-based errors, measurement errors, where we simulate false positives and OCR failure, reported not owned, where we study if treating not owned responses as frame error or non-response error does make a difference. And finally, response mode, where we test whether there is a difference in terms of underreporting between manual data collection modes and an automated data collection mode. I will explain all these potential alternative explanations now in more detail. So, first of all, reporting errors. This simulation is done or applied to the survey observations only, and also only for the number of vehicle days, because it would require strong assumptions to apply these simulation for the transported shipment weight. Okay, so survey respondents must fill out the day of loading instead the day of driving. So we consider this as a type of reporting error by design. If you think about the response pattern in a string, so you can think about having a string giving a range from 7 zeros, indicating the truck was not used the entire week, to a string of 7 ones, so the truck was used on every day of the week. In the underreporting error scenario, we replaced each trailing 0 with a 1. So for instance, if you have as you see, you have a string only with 1, 1, this becomes a 1, or the 1 is followed by ones. So we have more reported trips here. By this, we attempt to correct for day of loading versus day of driving, and for respondents pooling multiple days to the first day of reporting. The over-reporting error scenario, here we replaced each trailing 1 with a 0. So as you see, the string is filled with 1s, and the result is a string containing less 1s. This is not a main concern, but we use that as a control to show the opposite effect of underreporting. Measurement errors. This simulation is applied to the sensor observations and is applied for both target variables. In the false positives, or the false positive scenario, which is shown in the upper table, there are vehicles not driving for transport purposes, and in that case they do not need to be, or that trip does not need to be stated in the survey. But we might link them falsely because we do not know from the sensors if that truck is driving for transport purpose or not. And the effect of these false positive links were simulated by removing units from the cell M21. Second, we simulate OCR failures, so we have the sensors have the problem that they do not recognize every license plate. That's in about 30% the case. We simulated that effect by M11 and M21, decreasing those two cells by the same percentage, and M21 was increased by the same amount that M11 was decreased. Reported not owned. So in the analysis, vehicles reported not owned were treated as frame error and excluded. The reason for that is because it's unknown whether they can be measured by the sensors or, because they might have been scraped or exported. This implies that all sample units classified as non-response are assumed to own the vehicle, which means that if the vehicle is not owned, then it's assumed that this is always reported. In the official or in the published official statistics, vehicles reported not owned are treated as non-response error. So we have these two visions here, which we now compare by re-estimating the amount of underreporting when treating vehicles reported not owned as non-response error. And finally, the response mode. Here we test the hypothesis that the difference between survey estimates and capture estimates is due to manual underreporting in the survey. For that, we stratified both estimators by response mode, with the one strata being manual and the other being the automated response mode. And the manual consists of internet and paper questionnaire, and the automated consists of observations using this software-based journey planning system. Especially large companies use that system irrespective of the survey. So if they get sampled, they just transfer their data, which they already filled in, irrespectively of the survey, to Statistics Netherlands. Okay, coming to the results. First of all, total underreporting. So this table shows you the survey estimates, the capture-recapture estimates, and the estimated amount of underreporting for both target variables, vehicle days and transported shipment weight. The upper two rows show the vehicle days and the lower the transported shipment weight. As you can see from this table, there is a difference between the survey and the capture-recapture estimate for both target variables. In relative difference, that's a difference of 18 or minus 18% for both target variables. So we can say there's a considerable difference between survey and capture-recapture estimate, which we take as underreporting. Okay, now to our potential alternative explanations. First, the reporting errors. This left part of the figure shows on the y-scale the total vehicle days. This right part shows the relative difference. On the x-scale you see in both figures the percentage of vehicles with reporting error, and in both figures the left panel is showing the underreporting scenario and the right panel the overreporting error scenario. Okay, the main result shown by these figures is that even if all vehicle owners would only report the first day of loading, the survey estimate would still be 10% lower than the capture-recapture estimate. This is here. But this means that's a scenario with 100% of vehicles with reporting error. That would mean that none of the survey responses is reliable, which is very unlikely. So in that scenario, still 10%, we find still 10% underreporting. The overreporting error scenario, which served as a control, shows that in that case the relative difference only increases. Coming to the measurement errors. First of all, the left part or left column of the figure shows the false positive scenario, the right column shows the OCR failure simulation, and the first row the vehicle days, and the second the transported shipment weight. What you see is, looking at this panel, the relative difference decreases with the proportion of false positives for both variables. Now on the X scale you see again the percentage of vehicles with measurement error. With about 75% of measurement errors, the survey and capture-recapture estimate would be the same, indicated by the zero line. The black line above the zero line would mean the capture-recapture estimate is lower than the survey estimate. Considering the OCR simulation, the relative difference is robust against linkage errors and sensor failure. Only here you can see the precision is compromised the more errors we simulated. Coming to reporting not owned, you see on the top the vehicle day variable, on the bottom the panel the transported shipment weight. Treating vehicles reported not owned as non-response error instead of frame error can only explain about 2 to up to 3% points of the relative difference. So you see here the frame error for both variables, and here the non-response error. In terms of relative difference, the distribution shown by the box plots are not the same, but differ not a lot. And finally, the response mode. The layout of the plot is the same as before, but just showing manual and automated response modes. What you can see is the relative difference is much lower in the automated than in the manual mode. However, there's still a difference in the automated mode. For shipment weight about 8%, and for vehicle days about 6%. So that difference suggests that there are other factors than underreporting which play a role. To conclude, we conclude that sensor data in combination with the capture-recapture estimator provides a valid tool to assess underreporting in survey questionnaires. We consider the study as a useful reference for statisticians in the field of transport research and official statistics if survey, sensor and register data can be linked and capture-recapture can be applied. Some of these alternative explanations we studied here can jeopardize this methodology and need to be considered closely, and in particular false positives. And this is also one of the limitations of our research here, that we were unable to estimate the amount of false positive links. As you have seen, this really can compromise the amount of estimated underreporting. Further, we did not study multiple explanations simultaneously, but separately. So there's still room, as you can see, for further research. If you want to read more about this, so in this first reference, this article was published in the special issue of the last BigSurv in the Social Science Computer Review. If you want to know all the details, you can read my PhD thesis, and what I presented today is currently under review in the journal mentioned here and hopefully published soon. Okay, thank you very much, and I'm looking forward to your questions.